Dear students, very good morning to all of you. So today the topic of our implementation is heap sort. As we have done in the class, we'll have review of this heap sort before the implementation, and then we will see one animation. After that, we will implement it in C++. So heap sort is a sorting algorithm which works by organizing the data to be sorted into a special type of tree, which is called binary tree, and it is called heap. So the three different procedures which we have applied on the heap are heapify, build heap, and heap sort. Now, this algo we have discussed in the class. Heapify picks the largest child key and compare it with the parent. If the parent key is largest, then the heapify quits. Otherwise, it swaps the parent key with the largest key child, so that the parents is now become the so that parent become larger than its children. Fine. So for that, we have taken this procedure in which we have heapify a comma I. A is the array of element and I is the root node from where we want to heapify. Then left L is equal to left of I, and R will be the right child of I. Now, if L is less than heap size A, and A of L is greater than A of I. A of I is having the largest element, so we have to check if it is having the largest element, then it is okay. Otherwise, keep it in the L. Similarly, if right child is largest, then keep the right child in the largest element. And if you don't find, suppose you find if largest child is not equal to I, supposingly, if largest child is equal to I, that means root node will be the largest one. And if it is not equal to I, then we are going to swap AI with the A largest. After going from the root node till the non-leaf node, we have gone through all the nodes in the tree, and then we'll find whichever the child is largest is going to swap the root. So we have used the build heap procedure. This we have discussed in the class. We will start from a by 2, that is the last child of the tree, and which is having children. Then last node of the tree which is having children. Then thereon we'll decrement the nodes one by one, and later on we will reach the root node, and we will perform the heapify procedure. Then heap sort algorithm, first of all we have to build the heap. Then we have to start from the A down to the level where one above the non-leaf nodes, and we will perform the heapify. Wherever the swapping is required, we will do that. And after going to suppose we are having uh, 1 as a parent, 2 and 3 as a child node. Fine. And when we have heapified the third node, then it will be decremented by 1. Then we will go to second node. Fine. And after, when we remove the element in order to get the sorted list, then heap size would be reduced by 1. So we'll have look at the example. So this is an array which is given to us 16, 4, 7, 1, 12, 9, 10. Now you will arrange these elements. Like 16 is a root node, so give it element 1. 4 is the left node, so 2 into I, that is 2 node will be 4. Third node will be 7. One node will be 4th, and the fifth node will be 12th, and your seventh node will be your 19. 1, 2, 3, 4, 5, 6 node will be your 19. So I'll just try to annotate it. So this is your sixth node. Okay. Now you will heapify it. So here you are seeing we have a tree 16, 4, 7, 1, 12, 9, 19. So 19 is larger than 7. So we are going to swap it in this form. Then what we are looking at, we will move to node which is 4. So this is 1, this is 2, and this is 3. So the last node which is having the child is 7 number. The node with the element 7, and it is node number 3. Then you will reduce it by -1, and you will move to the node that is 4, and it is number 2 node. Fine. And you will heapify it because 12 is greater than 4 and 12 is also greater than 1. So you are going to swap 12 with 4 because we have to move from left to right. We have to check which node is greater, and then we are going to swap it. Now you see now you will move to node number 1, and compare it with node number 2 and node number 3. Okay, so compare it with node number 2 and node number 3. Now you see left node is smaller than right node, so right node is going to swap the root node. That's why 19 is swapping the 16. So now heap sort, we have, I mean, two phases. The heap sort consists of two phases. First is build a heap from the arbitrary array, and then you heapify it. And when you sort the element in the decreasing order, it will become the main heap. When you sort the element in increasing order, it will become the max heap. And you know, in max heap, the parent is always the value of the parent is always greater than the value of its children. And in min heap, the value of the parent is always smaller than its children. So how to remove it? Now you see, when I'm going to remove the element number 19, the largest element will reside in the root node in the heap. So we will remove it and we will swap it with 7. This I've told you in the class how to do it. Now you see the heap size is reduced by 1. Earlier there were how many elements? 6. Now we are left with 5 elements. Now 12 and 16, which is largest, 16 will go up and 7 will come down. You have to perform heapification again. And now 16 is the second largest element, which will reside in the root node, and you are going to remove it. So when you remove it, it will be again, the heap size will be again reduced by 1. Now you can see the elements in the heap are now 4. Now 12 and 7, which is greater? 12. So 12 is going to replace 4. So we are going to swap 4 with 12, and 12 will become the root node. Now this is the third largest element. Next phase, we are going to remove 12. See, we have removed 12 and heap size is again reduced by 1. Now 1, 4, 7, 7 is largest. 7 is going to swap with 1. And 7 is the fourth largest element. So we will remove it. Right? Now we are left with this thing, and this is how the sorting is done. Fine. So now we'll see the animation. I'll show you the animation. See, this is an array, which is not a heap right now. So this is a simple tree where we have arranged the elements. That is array representation of heap is given to us. Now we will perform the heapification. Now you see the elements will be swapped one by one. See, now we have the last nodes which are having the children are 57 and 13. So 2 has left child as 13 and right child as 57. Now we will start with the 57 and we will try to perform the heapification. First of all, we will do the heapification. See, 3 is less than 57, so the tree is okay. So we'll not do any heapification on 57, fine. Although we have taken the 57 into the consideration because we'll start from right side. So 3 is less than 57, so there is no problem. Now we'll come to the left side. Now 13 will be swapped by 90 because 90 is the right child of 13 and it is greater than 13. See here from left to right, it has taken 2 and 9. Fine. You can do in from right to left or left to right, one and the same thing. There is no problem. But the order should be right to left because we start with the non-leaf nodes first. So here 2 is swapped with 90, then 57, and then we will move to the right tree. Now here 13 is swapped with 2 because we have to perform the heapification at the lowest level also. Now you see 25 is swapped with 9 on the right side, and 9 and 17 are less than 25, so we'll perform the heapification at the root. Now you see 90 is greater, so 11 will come down and 90 will go down. Now you again see 57 is greater than 11, sorry. So 57 is going to swap 11. So it is swapping. Now you see the tree is in order. Now the tree becomes the heap. Now we will remove the elements one by one. So last index is 3. 90 will come to the last index and 3 will come to the first index. This is how we are swapping I with the last node. Now 2 remove. Now 90 is in the sorted form and heap size is reduced by 1. Now take 2. Now 3 is exchanged with 57 because it is the last element. You have to perform the heapification first, then you will remove the elements. Now exchange 2 with 57. Now 57 in sorted form and heap size is again reduced by 1. Now you see 1 is there. So perform the heapification first, then we will apply 1. See, 13 and 25, which is greater? 25. So 25 is going to swap with the 2. And now exchange 17 with the 2. This is heapification. Now remove 25 and exchange it with 1. So it is done. So 25 is now out of the list and the array size is reduced by 1. Now last index is 2. So first of all perform the heapification. 17 will swap 1. 17, 13 and 17. So 17 is larger, so 17 will swap 1. And then 9 will swap 1. Now you perform the heapification. It is done. So 2 will replace 17 now. 2 will replace 17 now. And 17 will be removed from the list and placed in the sorted list. Then this is 1. Perform the heapification again. 13 will swap 2. Now 13 will swap 2. Then 11 will swap 2. Now you can replace 13 with 1. Now 13 will be in the sorted list and 1 will become the root of the tree and heap size will be again reduced by 1. Now come to the next node, that is 2. Now first of all perform the heapification. 11 will swap 1 and then 3 will swap 1. Now remove 2 with 11. Exchange 2 with 11. Now 11 will be in the sorted list and 2 will become the root of the tree. Now 9 will replace 2. 11 will yes, 11 has gone and 9 will replace 2. Nine will replace 2. Now 9 will be removed and replaced with 1. Now you see we are left with 3 elements. Now 3 will replace 1 as it is the highest one. And you are going to swap 3 with the 2 last because right child is 2. So it is going 2 upwards. And heap size 3 will be in the sorted list, so heap size will be reduced by 1. Now you have 2 and 2 will be in the sorted list and 1 will replace 2 now. Remove. Exchange 1 with 2. Yes. Now 2 will be in the sorted list and finally 1 will be in the sorted list. So these are your sorted elements. The highest index is reduced by 1 now. See the nodes in the heap are exhausted and array has become now sorted. So there are 2 types of sorting. One is in place sorting and another is out place sorting. So in place sorting is sorting where we do not need the extra space. So that is your heap sort, fine. And the sorting algorithm which requires the extra space like merge sort, they are known as out place sorting algorithms. In place sorting algorithms are algorithms where we require either one space or the space or no extra space for the sorting. But the algorithm which require the extra space for the sorting, they are known as outplace sorting algorithms. So we'll close this swap function. I explained it again. We have imported istream.h file, pony.h file, then we have imported time.h file, so that we can apply the clock function in the beginning and at the end. So then I have deployed the swapping function. Now we will use the heapify function because it is the main function of the heap sort. So you will pass the array, then you will pass integer n because that will be the number of elements and the root element, that is I, where the swapping has to be performed. Initially, you will write integer largest equal to I. Then you will give left child. So write an integer L is equal to 2 into I. Then you will write integer R is equal to 2 into I plus 1, because this is your right child. Now you have to compare. See, where are we performing the comparisons? They are known as comparison algorithms. For example, you have done in binary search, you have done in merge sort, you have always compared the elements. So they are your comparison algorithm. The algorithm which we have done yesterday in the class, that is bucket sorting. That is not a, comparison sort problem. So array of L, you have to check whether the left index is less than the last index, and array of left is greater than array of largest. The value at L is greater than the largest, that is root node. Then largest will be equal to L. Largest equal to L. So just copy it. And here you will write right is equal to N. Then array of R should be greater than largest and put R here. Then largest will be equal to right. This is the algorithm which I have explained number of times and we are just implementing it. If largest is not equal to I, then what to do? We have to swap array of AI with largest. Swap ampersand, since we have given the pointers. So you will write array I, comma, ampersand, array largest. Whatever the largest element will be swapped with the root element if it is greater. Then call the heapify because we are performing the recursion. Array, comma, n, comma, largest. In order to heapify, we will always call this. Then just close this procedure. Just close this procedure, and then we will write the heap sort program. Void heap sort. Integer array, which is being passed, and integer n. Now we will write the code for build heap. Then we will call for I is equal to n by 2 minus 1. Since we are starting from 0, so write down for integer I is equal to n by 2 minus 1. Column I should be greater than equal to 0 because we have to reach the last node, and I minus minus. Okay, now call the heapify because we have to build the heap. Heapify a comma n comma I. This is how build heap is done. Now we have to remove the elements after the heapification is done. For I is equal to n minus 1. I should be greater than equal to 0. I minus minus. This is to bring the elements in the sorted manner. So open the loop, open the braces and write down for I is equal to swap, then root node with the largest one. So A0 with AI, comma, ampersand array of I. Here we are swapping the root node with the largest one. So you will write array I because I will have the largest element now. Now again call heapify. Now you will call heapify till the 0th element. So we'll give the root node also. I comma 0. That is I is the node which is having largest element and the 0 is the root node. So this is done. Now you will write the print function. Pass the array and the number of elements. So write in for I equal to 0, I less than n, I plus plus, and print the elements. Cout array I, then give slash t and semicolon. Cout handle. Close this. Now you will get the integer main. Here you will deploy your clock. Start is equal to clock. Then we pass the elements in the array. Because start is a variable for clock underscore t, which is inbuilt function to import the clock from time.h. So now you will give the array. Integer array is equal to the elements you want to give. Any elements you can give. So 12, 11, 13, 5, 6, 7. Now you have to find the number of elements in the array. So that will be given by size of array divided by the size of first input, the first number of the array. Size of array 0. So close this and you will get the n elements. Now you call heap sort. Array comma n. Then print array comma n. Then finish is equal to clock. Here you are finishing your program. So I'm writing this. Now you will write cout. Time taken will be, here you can write time taken to sort the elements would be, that is double of, because that would be in milliseconds. So you will write double of finish minus start. Minus start. Now return 0 since we have taken integer main. So return 0 and close this. Now let's save it as .cpp. Now let's compile it. So I missed one brace, putting one brace here. So these are syntaxes error which I have removed now. Let me run it. Alt F5. So this is the element which are sorted 5, 6, 11, 12, 13. When we take larger inputs, then definitely the time would come in some milliseconds. Fine. So it is giving us 0 because the elements are small in number. When you give the larger elements, then only you will get the time taken. You can take the larger inputs, you can take the 1000 inputs, and then you can sort and get the time. Fine. So thank you so much. In the next session, you are going to implement this and share the screen with me.